Hello, ngHouston. So I'm super excited tonight because we have Martin from Berlin. We're going to introduce the panel. So first, I just want to say a little bit because we're doing lazy living strategy. I did not go to NG Vikings this year. I knew about NG Vikings. I forgot to mute my thing. Okay. I was super jealous because I was watching Twitter and I saw all my favorite people at NG Vikings and I was like, all my friends are there and I wasn't there and I was very sad. So Martin is bringing a little bit of NG Vikings to us tonight with his lazy living strategy talk. So I thought that was really a good talk. So I'm really happy to have him. But before we get to Martin, let's introduce our panelists, starting with Bill Odom from Angular Bootcamp. Say hello, Bill.
Hi, everybody. I'm Bill Odom, and it's awesome that I get to introduce myself first because there are two other Angular Bootcamp people on the panel, and I'm going to go ahead and steal all their stuff. So I'm an instructor for Angular Bootcamp, do a lot of independent consulting, typically with the same company that those other folks work for, Oasis Digital, and super happy to be on the panel because we love Bonnie.
Well, Bonnie loves you too. And you guys are great panelists, so I'm really happy to have you guys. And that brings us to Paul and Rachel. And Rachel's a new face. Well, Rachel's not a new face for me, but Rachel's a new face for ngHouston because we have not had her on the show before. So why don't you guys say hello?
Hello, hello. I'm Paul Spears. All the things Bill said, except better.
Yeah, that's how you do it.
You guys are terrible.
All right, and I'm Rachel Natoli.
Rachel, we're very happy to have you, and we hope to see you on lots more ngHoustons. Don't worry, we're very nice. We don't bite. And that brings us to Martin. And I have to tell you guys before we start, Martin it's like 1:30 in the morning over in Berlin. So Martin is a trooper, but Martin's jet lagged. So he can't figure out what time it is because he's in Berlin, so it's 1:30, but he just got back from Japan, so it's like in the morning, but he's speaking in Houston, so it's night. So Martin's all over the world right now. So Martin, you're a champ for staying up so late to talk to us. And you have to like explain complicated code stuff to us at the same time. So that's going to be pretty interesting. We'll be impressed. Say hello, Martin.
Hi, everyone. Yeah, I'm Martin. I'm from Berlin. I do the Angular Berlin meetup. So we don't do fancy live streaming like Bonnie does, but if you come to Berlin, just join us.
And I had a hard time finding you. I was in London. So I had met Martin from NG Community, which is Maxim's group, and he has all of the Angular meetup organizers all over the world, and he just kind of gives us a way to talk to each other and compare notes, and I love it. And so I had met Martin through that group, and I knew he was really cool, but I just couldn't remember where I knew him from. So I went to London and I started looking for him. But the problem is, there's no picture of Martin. Like there was a picture of a cat because his Twitter handle is chaos_monster, right? So there's just a picture of a cat. And I didn't know what he looked like. And I knew he was at Angular Connect because he was tweeting about it. So I'm like looking around and I'm never going to find the guy because in real life, he doesn't actually look like a cat. But I tracked down WebDave and WebDave brought him to me. And then I took his picture and put it on the internet apparently for the first time. So sorry, not sorry. So now we know what you look like and now you're here with us. So I probably freaked you out. It's like, hey, some girl wants to meet you and you didn't actually look like a cat in real life.
But I had the cat T-shirt on. I had a T-shirt on where the counterface of my Twitter handle was printed on. So yeah. But Dave came to me. So hey, Bonnie wants to meet you. She has not many times. So now, quick. Okay, where is she? We ran around the venue and finally found Bonnie. So it was really funny. So yeah.
I can imagine. And you're like, who the hell is Bonnie? And why does she want to meet me? Yeah, but we were friends from NG Community.
I knew you from Twitter, so yeah.
Well, I'm glad we met. We're kindred spirits. So I have a meetup over here, and you have a meetup like, I don't know if it's technically on the other side of the world, but that sounds really cool. So we'll just say it's on the other side of the world. We're very international around here. So you know how to share your screen. Do you want to share your screen and just jump into your presentation and show us? There's some lazy loading strategies that I thought were really cool, and I thought people would be interested. And I know that this is already on YouTube, and you guys are like, why are you doing this? Because we already have this on YouTube. But at NG Vikings, you only had 30 minutes for your talk. And there were a couple things that I wanted you to kind of dive into a little bit more. So now in this context, you can kind of go into a little bit and we can heckle you and ask you questions. And you're going to show us maybe a little code if we have time. So this will be like your presentation with bonuses, with bonus extended content.
So don't don't feel shy to interrupt me, or if you're in the chat, just ask questions. I think Phil and Rachel will jump in to tell me them, because I can't see the chat right now.
Yep.
Yeah, let's start. Okay. So we are going to talk about lazy loading and preloading strategy. Not like I did at ngVikings, we will do a little bit more about how basic preloading strategies work in Angular, and then go a little bit deeper into the different solutions to do more complex custom preloading strategies. Short introduction, Bonnie already did that. My name is Martin. My last name is, if you're not German, that is really hard to pronounce for many people, so Martin is fine. I work for a company called Idealo, and that is where the basic idea came from for this talk, or especially from the machine learning part. And I'm also organizing the Angular Berlin meetup. So if you're in Berlin, or you can probably find me on any community meetup that is currently about JavaScript or something like that. I'm really into that, all that community stuff, and I'm really liking it. I love Angular. Yeah, I do the Angular meetup. I work with Angular at my company. I love math. I studied math, and I love cats. So that's the reason Bonnie didn't find me at first at Angular Connect, because that is my cat, and his nickname is also my Twitter handle. So if you have any questions afterwards, just follow me on Twitter or give me a shout out on Twitter, and I try to help you. So performance is and using lazy loading. If you use lazy loading, you really get easy performance just from startup, because your applications will start faster. You don't have to load all the bulky stuff at first, but you can have a small shell application, and that makes it easy to increase the performance just on the startup. Also, the app size itself of the initial app is minimized, and for that reason, you can easily load the application and interact with it before you have to load all the modules that are getting really onto your payload when it comes to pushing them over the internet. For lazy loading, you need routing modules. Later, we will have a little bit look into code, and I will show you how to do that. And you can use preloading strategies to manage the fetching of those lazy modules. There are 2 custom preloading strategies. We will look into them too. And you can do your own custom preloading strategies. And of course, we will have a look into them as well. So lazy loading in a nutshell, we go a little bit slower, go a little bit deeper. We will do a little bit of live code review. So this is what you need for a module. It has to be a module that uses a router module, and the router module has 2 methods: for root, what you need to do your routes in general, and for child. Every module that has its own routes needs to have a for child and pass the array of routes there. And in your main application, where your for root method is on router module, you can specify the routes as you just expect them to be, and you can use load children to tell Angular where to find the lazy module. And Angular CLI will do a lot of magic under the hood to translate this code into chunks of code for the lazy loaded module, and replace the URLs so that if you go on the site, it really can load the JavaScript from the correct places. You also have the possibilities. That's not special to lazy loading, but that's how the router and the router configs work. You have the possibility to add just data. And we will use that data, for example, just to tell a custom preloading strategy that this special module A route should be preloaded and module B shouldn't be. So
for this part
preloading
of it,
strategies.
Can I ask you a question?
Sorry?
I mean, I understand this, the lazy loading in general. If you're using the CLI, right, that's pretty much it. I mean, because I had said, hey, spend a little bit more time on the intro, but the thing is that code that you showed us is all you need to do. Like, if you just have 4 children, you're using lazy loading. It's not like there's a lot of configuration that's complicated that you need to set up. I mean, that's it, right? You just showed us.
Right. We can just jump into code and look at how this works.
So if you're new to Angular and you're watching and you really don't know and you haven't done any kind of lazy loading thing before, then that's all you need to know right there, what you just showed us. I mean, for that part of it, for just lazy loading is that simple?
Well, can I ask an opposite version of that? You're saying, so, that's all you need to do if you're using the CLI. Like, can these things be done without the CLI? Like, are there other kinds of tools out there?
To be honest, I do not know if there are tools out there, but in the end, it's just Webpack that is configured by the Angular CLI to do all the chunking and replacing the strings with the URLs and stuff like that.
Sure.
So you probably definitely should be able to do it with Webpack. I never did it without Angular CLI.
I did it with Webpack before the Angular CLI, and it was much easier with the CLI. Why would you do it without the CLI? Why would you do that? It's so easy. But yeah, Webpack will do it. But also, that was the thing, is like, I put lazy loading on the list of like one of the things I need to learn. But then I realized, like, I just learned it accidentally, and I didn't really have to do anything. So once I started using 4 children and load children, that's it. But then I had asked Martin right before this to like go through the intro stuff a little bit more, just in case we have people watching that aren't. But then I realized when he was talking about it, I was like, well, that's it. That's pretty simple. So then we go into the next section, the custom strategies that you came up with, which I thought were pretty clever, but they're also very, very simple.
Right. But just to show it how it really looks into in code, because I just had a small part. This is just a normal Angular application built with the Angular CLI. We have a few modules here. Don't bother that there are so many. And we have the app module, and the app module has the routes array, and the routes array is passed to router module for routes. And that is it. You can have the load children, and what is important here, this needs to be the relative path from this app module file to module module TS to this file. So that is important to know, that if you do load children, you have to do a relative path from here to here, and the hash at the end is just the name of the module. So normally you just have one module in a file, but you could have more than one module in a file. So Angular needs you, or the Webpack, the configuration, the Angular CLI needs you to specify the name of the module you're loading. So this is module A module, and this is just the name of the class that is exported, and that is it. And here you can also see.
To notice, I think, correct me if I'm wrong, if you want to lazy load it, it needs to be a separate module. If you have a whole bunch of components, you can't lazy load them unless they're broken into separate modules. Is that right?
That is right.
You can't lazy load a component.
You can lazy load a component. You just can lazy load ng modules. To be specific, you can. It's not about the modules of ES 2015. It's about ng modules. Right. You have to have that, and those ng modules have their own routes that are well, the route itself is concatenated. So this is the module A, and module A, if I run it on my local machine, it will be localhost 4200 and slash module A, and then nothing, because here is nothing. But if I add something like foo here, it would be module 8 slash foo. So you can just specify a bunch of routes that are all after module A on your route. So maybe just start it. I just should start it up, right? That sounds like what you should do.
Do it.
Do it. Okay. Maybe you shouldn't see that.
I forgot to warn you. Sometimes it's hard to do this on live stream, because sometimes we'll ask you questions and distract you right in the middle of it, and then, but it's fun.
No, it's okay. We will figure it out. So I saw you had a panel with Justin, and he was talking about NX. So this repo that is on GitHub uses NX to just have multiple Angular applications, and I will start the basic lazy loading application. Just give me a second to figure out if that is the name I chose. Project apps basic, which basic lazy loading. Here we go. So,
Martin, when you have a second, could you bump up the font size on your windows a couple of points?
So like that? Too much?
Oh, that's great.
More? Yeah, cool. So while my I do it with the font size in WebStorm in general, so that should be better. Font size, general font size. Let's make it 25, 24. Did that work? No, that didn't. Okay. So yeah, it works. So we can have a look at basic lazy loading. Just check out if the font size is better. The font size is better. Perfect.
It's one of my favorite things about it when you guys live stream. Yeah, does that work? Yeah, it works. Of course it works. We're live streaming here.
What could possibly go wrong? So this is the application like we just ran it, and if we reload it, we see just a bunch of JavaScript files that are loaded, and the URL to module A is just that module, and it does a lot of stuff on the side, on the right side. So you can see here, you can see that it loaded the chunk module A module, and it did that because we did lazy loading. And if I go to module B, it will change the URL, and it will reload another chunk of JavaScript. So, well, now we got into how lazy loading, how you can figure out if your lazy loading works. But if I want to change, for example, in module A, the route to foo, what we just did, we look at recompiling, perfect. If we go to module A, it doesn't work now. It shouldn't work. It brings us back to the standard page, and now we have to go to foo. And this brings us to the code that is created by the module A component. So with that, we could just add as many subroutes as we want and make those module A or those ng modules just, well, define themselves how their routes should look like. So that's really cool and a really awesome feature, especially if you want to decouple your modules. Right. Let's jump back into preloading strategies. They're also really simple.
I have a question.
We have preloading strategies. Sorry?
I have a question, actually.
Yeah.
Back over in the running application.
Yeah.
So you have the network tab there. So if you were to like go to route B, go back to A and go to B again, does it fetch that a second time?
No, it doesn't. So that is the magic of Angular or Angular router. It goes to module B. It knows that it already loaded it because it had to request it. You have to, no, that was the wrong one. Module E. And we just did a round trip on the and loaded a bunch of modules here.
Yeah.
And if you go to module A, you can see nothing changes in the network tab. So everything that is loaded won't be loaded again.
Cool, thanks.
So it's quite smart about that.
That's pretty cool.
Perfect. Yeah, it's not my. You have to thank the Angular core team for doing that awesome stuff. So preloading strategies, just in a nutshell, or just to talk about it a little bit more. Preloading strategies are just a second parameter in the for routes of router module. It's in JSON where you define preloading strategy, and here you see one of two built-in preloading strategies. Angular comes with two preloading strategies. The one we already saw is preload nothing. That's the default one. That means Angular just loads ng module when you hit the route that defines the module itself, and preload all modules just goes through all your lazy loaded modules and loads them after the initial app is loaded. So this is a perfect solution if you have a small application and you want to have a really quick start. You want to have an app shell and an initial loading. And if you, after you load it, you just want to load everything else. So if the user starts switching around, he or she will have no impact on you loading all the stuff lazy. We will also have a little bit of a look into that. For that, I should open preload all. You can really see preload all is the same application as basic lazy loading, except that I added this config object, and I'm going to do the preload all modules. You can see I jumped into the preloader DTS file, and I'm now inside the Angular core. It is also imported from Angular router, not Angular core, I'm sorry, it's Angular router. And what it does, it goes through all the routes that are defined in for root. And if it finds a load children, it just loads this module. So if we spin up this application, basic preload all, just kill the old one. That's the name. So if you remember with the previous version of the application, it just loaded the JS files, the chunk files, whenever we hit a route. Now it will start the application, and I did nothing. It just loaded all the other modules. We started with module A because we started in the module A route, and it just preload everything else from module B to module F. And that's it. So this is the perfect solution if you have a small application with various modules and you want them to be fetched after you started with the initial loading. With this strategy, you have everything you want if you have a small application.
So Martin, let me ask what may be an obvious question here. What is the difference between lazy loading everything but preloading everything versus not lazy loading anything? Just
I think I know. Can I answer that, Martin?
Yeah, sure.
I think I know, so you have to tell me if I'm wrong. So if you preload all the modules except the first one, the benefit from that is that what it's going to do is, rather than trying to load your entire application and wait for a while, what it's going to do instead is it's going to just load the first page, the first thing, the route that you're telling it to load that and show it to them immediately. And then while they're looking at that, then load all the rest in the background. Yeah? Am I right?
Right. Yeah, it's just about the perceived performance. So if you start with all those modules, I'm in dev mode, so but those modules do not have any really complicated stuff in them. But they're all about 10 kilobytes ungzipped, of course. But if they have more code, your browser has to load all that. Your browser has to execute all the JavaScript before you can see anything. And as Bonnie just said, it's just has a better perceived performance on your startup time. Cool.
Thanks.
Any further questions?
That was a great question, Bill.
Thank you.
So, custom preloading strategies. Custom preloading strategies in a nutshell. What Angular does is it gives you a interface called preloading strategy, and this interface just has one method called preload, and preload has two parameters. One is route, that is one of those route objects we had in our for root array, and a function called load. And what you do, you return an observable, and the load function, if you want to load that route, you just execute the load function and return the observable that is returned by the load function. Or if you definitely do not want to preload this strategy, you just return an observable of null. This is really important because this is how we will use it later on in some custom preloading strategy that are more advanced, more sophisticated. Right, and we will have a look into that too.
So can we use that code for a second, just a little bit longer? So I'm trying to understand that line 3 on that code that you had up there.
I'm going to exactly that same
cool.
Code example. So the code I wrote in the application in the GitHub repo are all the same code. So we have this custom preload strategy. That's just a file. I just put it next to app module. Feel like a little bit too large on that side. Perfect. And let me show you how preload nothing would look like. So preload nothing would look like that. You just return an observable of null, and the preloading strategy would do exactly nothing. It will say for every route that it will do nothing. Preload all would look a little bit like, let's copy that. Preload all would look like that. That is what the preloading strategy, preload all modules, would look like. You just return the results of the load function, and here you see the what the load function looks like. It just is a function without any parameters, and it returns an observable. And to go back, this is just an example where I use the router module route data. So if I have a look back at app module, I just added on a few routes. I just added the data JSON object, and I added a preload true in there.
So this code here, this runs like after you've already built your application. So this isn't really whether to build the bundles in chunks or build it all as one thing. This is about, you know, assuming that you've already kind of built it in chunks, whether or not we're going to preload it or greedy load it. Is that right? Or lazy load it?
It just tells what Angular does. We have in the app module, we define where we define the preloading strategy. We just use the custom preloading strategy I showed you. It's an Angular service, and we just tell it, okay, use custom preloading strategy. And what Angular does is it what the router does in an easy to say way. It goes over all routes that have the load children, and it executes this function preload with this object as the first parameter, and this function just defines if you want to preload it or not. This has nothing to do with your build time when we execute it.
So the or not there means that it'll be lazy loaded?
Again?
So you said whether or not it will be preloaded or not. So is the result of this meaning that it'll either be preloaded or lazy loaded?
Lazy loaded. I'm sorry. For me, preloading and lazy loading is the same.
Yeah, I mean, they're kind of the same. Like, it's either loading it immediately or after it loads the first module, or it's not loading it until the user goes to that page.
Okay, yeah, that makes sense.
So in this basic example where I just check out if a data object exists and if it has a property called preload, and that is true, that's just this line. Do I have a data, and does it have a preload, and is the preload true? Then I will load it. If not, I will say to Angular, do not load it. So I spin up this application, and what you see.
So while you're doing that, just to recap, the way that you've written that code is, if you go back to the routes file, you should, well, if you don't specify anything, then it'll do false by default. But if you do preload true, so you're just picking and choosing what you want to preload on that page and just putting in the route file. And if you don't put anything, that's fine, and it'll just go to the default.
Right.
So this is one strategy where you can really cherry pick exactly what you want to preload just on the routes file.
Yeah, that's the next easiest way to preload all. Just tell the application to not preload anything that has not the data object here. Oh, I saw the person tweeting who I stole that example from. Hello, Corin.
Did you steal it from Corey?
Yeah, more or less.
Also,
he had the same idea.
Corey Ryland, you know Corey Ryland?
I do not know him, but he had it on. I do not know him in person. I know him from Twitter, and he had this example. Victor has this example, so that's the reason I just picked that example to be consistent with all the custom preloading strategies out there.
Yeah.
So if you look for,
we love Corey. I'm going to do another
awesome
chat
content
on Twitter, so he'll know we were talking about him.
Right. Perfect. So we started this application, and we have let's just have a look at which modules we set to preload. It's module A, it's module C, and we said that module F should be preloaded. And if we start module A, of course, module A will be loaded because it is the first route we decided. So we loaded module A, module C, and module F. And module B, D, and E won't be loaded. Module B, will be loaded if I go to module B. So here you can see module B. And if I go to module E, it will be loaded. So we just had a kind of cherry picking for preloading as a preloading strategy with that custom preloading. That's just it. That is custom preloading strategies. And from that, we will start to go more into detail how to do more sophisticated scenarios. So we started with a really small application where we had just a few modules, and we wanted to improve our startup time by using lazy loading and preload all modules. Now we got into where we say, okay, some of those modules shouldn't be preloaded because we don't need them really that often. For example, if you have an admin settings panel, that is probably not used that often. So maybe we don't want to preload it. We just want to preload those modules that are used really often. We covered that with the custom preloading strategy I just showed you. And the next thing is to think about scenarios where custom preloading strategies could or should be a little bit more complex. And let's jump into the slides again. So scenarios where you need a little bit more. If you have low-end devices in my my personal definition are smartphones that do not have the latest and greatest CPUs and some small cheap smartphones or stuff like that. And also you can have low-end devices on your desktop. For example, in my company, we have a really large content team, and their PCs are just 2 or 4 gigabytes of RAM. Compared to my MacBook I'm currently working on, it has 16 gigabytes and 4 cores, so it's quite good, let's say that way. And if you have a lot of tabs open and a lot of Angular applications, and you're running just on 4 gigabytes, you will really feel that you have large applications. So that is a low-end device in my personal definition. If you want to add something to that, please feel free. And the second thing is slow connections. So I'm currently, I think it's the same for most of America. You have quite good internet connection if you have Wi-Fi, but there are also areas around the world where slow internet connection is just normal. If you go to smaller countries, you don't have to go that far. If you go to the countryside of Germany, you will have really slow edge internet connections. So you don't want to load everything. You don't want to load the module that is on that you use rarely when the internet connection is really slow. And the third scenario is if you have really large applications with a lot of routing modules. This is where all the behavior-driven stuff that I will do in later part of the presentation will come in handy. So, of course, you can have also a combination of those three. So I will add to this. Everything we did until this point was just to just easy way, low-hanging fruits to add quick perceived performance. Everything we did with the custom preloading strategy was to cherry pick if we have really a good feeling of what is needed. And everything that comes from now on is you have to think if it's really that if you really want to go deep into that, because it has a little bit of effort to collect the data. It has a little bit of effort to write the code and to maintain the code. So I found this awesome quote by Yanni about Redux, and for everything that comes from now on, it's more or less the same. It's really improves your application, but it comes with a little bit of effort. So slow connections. Wouldn't it be awesome if there is a API on your browser that tells you that, well, what connection does my current computer have? And it turns out there is an API for that. It's navigator.connection, and then there is the property called effective type. Effective type is just a string that returns one of those 4 strings, 4G being the high tier, 3G, 2G, slow 2G. And we can look at this just by going to the console of our application and type in navigator. That's connection, connection. And this is just an object that has a lot of information, the effective type, on change, downlink, and so on. So now you know what my internet connection looks like. If I go to the network tab, that is a trick. That's a really good trick you can use in Chrome. You can change the presets of your application. You can go faster than you actually are. But for example, we can go to slow 3G and do the same thing again. And it didn't work. Oh, it just works on how you load it. But in the end, you just saw it because my internet connection just got a little bit better. It always tells you the current state of your connection. The problem with that is, let's do that, return it back so I don't have problems later. The problem with that is this is only on Chrome. So you don't have support for Safari, you don't have support for Internet Explorer, and Firefox is the same, and on the mobile side, it's also not that good. So that would be the perfect, would have been the perfect thing for us to tell if the internet connection is fast enough. But we won't have it on all browsers that we need. So if you're lucky and you just have to develop for Chrome, that would be perfect. If not, we should do something else. So I found two solutions. Those solutions are not, they don't give you the perfect speed information of your current user, because if you want to really measure the connectivity of your browser, you need to, sorry, I have to turn that off. You need to load up and down a lot of files, and that is not what we want. We want not to upload a megabyte of file or download an image with 4 megabytes just to figure out how fast our internet application is. That is the opposite of what we want to do. So we just want to have a rough estimation of how fast our connection is. One thing I found that is really helpful is using timeouts. We start with a timeout in the index.html file, and we clear that timeout on a specific JavaScript file, and that JavaScript file has its own size, and for that reason, it needs some time to load that file. And if it loads fast enough, the timeout will be cleared. If it doesn't load fast enough, the timeout won't be cleared. So what would be a good file, in my personal opinion? There's no good or no right or wrong on that. I would use the polyfill TS file, just because if we have a look at the networks itself, we have the index.html file, we have the inline bundle, then we have the polyfill bundle, then styles vendor, and then we have the main bundle. And with the polyfill file, we have a more or less consistent JavaScript file size, because we do not add too many polyfills on a daily basis. We do that once in a while, that we add or remove polyfills. And so the size of the file stays roughly the same for each time, and you don't have to change your timings every time you build, because this is a little bit where you have to trial and error to find out the good thresholds. So what does it look like? You have a script tag in your index.html file. The index.html file, if you look at any Angular application, we have this index.html file, and the spot I would suggest is just line 3 on any index.html file, and you can start there with a script tag. You add various booleans for slow, fast, intermediate. You can add as many as you want to, and you add timeouts. So you set a timeout for example, 3 seconds, 500 milliseconds, and that's basic JavaScript. The timeout will execute the function that is the first parameter roughly after 3,000 milliseconds.
Hey, Martin, I want you to stop here for a minute and show them, just let them soak this in for a minute, because when I was watching your NG Vikings and you were going through this, and it all sounded a little bit, no, you just went off it. What are you doing? It all sounded a little bit, you know, I didn't really understand, but when I saw this code, like, this is so simple. It's just this code. So this is just a little bit of custom code that you wrote to use for your preloading stuff. And it's super simple. I love this.
Right. And as I just said, those timings you have to play around with your application to find the perfect sweet spots for those numbers.
Kyle just mentioned on the chat that you could actually, because this is just a little tiny bit of JavaScript, you could actually put this inline in a script tag in the index.html file, right?
That's exactly where I would put it. I just would use exactly this script tag and put it here. So what I would do is script here, set my window marker, false.
So Kyle's right. You're right, Kyle.
Yeah, that's
Good
exactly
tip.
where I would do it. This is important to be really, really, really on the beginning of when JavaScript is executed, just to use the you don't see it in the index.html file before it's compiled, but if you look at the index.html after it is compiled, you would have it just here. And then you have on the bottom of your body, you will have the script tags for inline, polyfills, styles, vendor, and stuff like that.
Mm-hmm.
So this is the perfect spot to start the timeout, and the perfect spot to stop the timeout, to clear the timeout, would be in your polyfill file. So for that reason, you had the inline file and the polyfill file to be loaded by your browser. So you had a little bit of overhead loading data through the connection, and you just clear all the timeouts you created on the index HTML file. And the thing is, if the polyfill TS file loaded fast enough, for example, this timeout function, the slow marker equals true, is set to true. This will never be triggered, so slow marker would still be false. But if it took me more than 500 milliseconds to load polyfill TS and execute the JavaScript file, we would also have the fast marker to be set true. And with that, you just kind of have a combination of markers and timeouts and for milliseconds to figure out what kind of connection you have. To be fair, this is not precise. This is not meant to be to say, okay, I'm on 3G, I'm on 4G, I have a 2G connectivity, because this also means that it includes the time that your browser needs to execute execute JavaScript, because there is already JavaScript. So you also get a little bit of an information about if you have a low-end device or a high-end device, because high-end devices tend to execute JavaScript faster than low-end devices. So this is not 100% slow connection detection, but this is a combination of both in a way. So do not try to tell your user, okay, you just have 2G. I will make you slow. Just use it as a benchmark, more or less. You could also use, if you don't like the timeout, you could also use something like that, where I just add a start timing I get a date and I take the timestamp, and I use the same place in the polyfill file to set an end time and just calculate the time it took me from the index.html file to executing the polyfill file. That would be a second approach. You have to figure out what you want to do. Both are valid. Both have the same disadvantage of not saying exactly how fast your internet connection is, and also you also have to remember that the JavaScript itself to be executed will push on those numbers. But that's fine, because we also want to have not only want to have slow connections, but we also want to have low-end devices. Right. Chat, any questions about that? What do you think about that?
I love that.
Not responding.
No, I think it's really cool, because it's, like I said, the code, you wrote a little bit of custom code to do that, but it's so clean and simple. And I know there are probably a lot of developers out there that don't need to think about this, but for the developers that do need to think about stuff like this, I think it's a really simple and elegant way to do it. And I like the strategy a lot.
Right. So especially if you're going into mobile, you're building mobile applications, and especially if you think about building mobile applications for emerging markets like, well, Africa has quite good internet connection, but like the countryside of Germany, where nobody has good internet connections when they are on mobile, it's really important to think about that. And this helps just to get a glimpse of how they do, how the code is going. Right. Cool. Low-end devices. We had an API, at least in Chrome, to detect the connection. We found a way out to do the calculating, let's say, that way of if we have a slow connection or not. Low-end devices do not have a real API but we have a lot of informations on various other APIs that we can have a look at to define if we are on a low-end device or not. So, for example, the window navigator has a lot of information, and I just want to point out those three informations that are available on the navigator. Hardware concurrency gives you the number of logic cores. For example, on my MacBook right now, I have a quad core. It would return 4. On a low-end device with just 1 core, with a single core, it just would return 1. Also the user agent and, of course, the platform. So if we have just a look at what those hardware concurrency, what they return, you would see 4. I'm not sure if I can somewhere. I can memory? No. I've seen somewhere to change the.
I know what you're talking about. I can never remember. To change to throttle it.
Yeah, to throttle the cores you really have in Chrome.
Yeah, and your device simulation, you should be able to I'm trying to point at your screen and you're not able to see it. I wonder why. Right next to where you were on the Elements tab, if you flip into device simulation mode, you should be able to tell it what kind of device you have.
Second from the left.
Second from the left. Oh,
I think
no,
he's talking about the other left, the icon. Josh says it's in the network tab.
That's for network only.
Oh, so if you look at the little icon right next to the picker, there's like a.
Go to the Elements tab and then go left like a centimeter.
Yeah. Up.
Up, up, up.
Oh, you almost said it.
Oh, yeah.
No, yeah.
So we use that all the time, right?
There you go.
If I use an iPhone X,
we did it, everyone.
Of course.
Woohoo! Is that what you were looking for, Martin, or did you just click it because we were
that was what I was looking for, right? Okay. And you can throttling. Here we go. You can throttle. You can create smaller. I don't want to bash on any of those.
The old flip phone.
But you could throttle the connectivity here, and you could do. Can you change the number of CPUs? Never mind. If you run the same code on another machine, it won't return 4. It will return the number. The second thing is, and this is not new to anyone who did a lot of user tracking in the past. So user agent just gives you a long string, and there are a lot of pages out there that helps you to define if you have, for example, now you can see I'm using the iPhone X here, and I have an iPhone. I use Safari, of course, because Mozilla and Apple WebKit, because it's Safari. If I go back to my normal stuff, this would be Mozilla on a Linux, and we would use Chrome. And with this information, you can have a lot of ideas on how fast or slow your device is, because if you this is where you just have to pinpoint and say, okay, if I'm on Chrome and I see Mac, that is platform.
What are you trying to say
Mac
about
Intel,
those Chrome Mac users there, Martin?
Yeah, well, if I have Mac Intel and I use Chrome, I'm probably on a desktop machine, and I'm probably have a quite fast machine. If you see Chrome on an Android device or on a mobile device, you definitely can say that you're not on an iPhone. iPhone should be faster. I'm starting to.
Wait a minute! I have Chrome on my iPhone. What are you talking about?
But the thing is, if you look at the statistics, there are not that many people using Chrome on iPhone. So I'm going here into the same thing you see when you do your Google Analytics. You see, I don't know, 40% using Chrome, 20% using Firefox on mobile, and the other 40% are Safari on mobile. I just talked about mobile right now, not about desktop. And you won't see.
I can't decide if I'm special in a good way or special in a bad way, but at least we know I'm special.
Yeah. As long as you do not use Netscape, everything is fine.
But I really like Internet Explorer on my iPhone. I'm kidding.
Is that really a thing? Okay.
No,
we're
it's not.
Disconnected here. But those free, for example, if you use those free APIs, you know now, okay, I have 4 logical cores. I have a user agent that says I'm on Chrome and I'm on a Mac Intel, so I probably have a high-end device. If hardware concurrency would be 2 or 1, you definitely would know, okay, I'm on a low-end device. If you see on your user agent that you are on a Android phone or on an iPhone, you definitely know that you're on an old version of an iPhone or a low-end device using Android. So this information gives you a lot of ideas what to do and what to use. Where you would do that, I do not have code for that, but in the end, it's just this custom preload strategy where you would do your where you would go into saying, for example, okay, the window navigator hardware concurrency is 4. Do preload, the hardware concurrency is 1. Do not preload and stuff like that. So, yeah. Right. Perfect. Let's go. Any further questions?
Martin, you mentioned very early on that there was, you know, a bit of information that you could get only on Chrome about like network quality or network speed.
Yeah.
Do you know of a good polyfill that makes that available on other browsers? We mentioned, you know, using polyfills earlier for things, and it made me think, you know, I'd love to have that. How about if I just install a polyfill that made that work on IE or Firefox or whatever? Is there one that you know of?
I didn't have a look into polyfills, but a polyfill would definitely mean that you download big data files. So do you know pages like Speedometer, for example? Something like that. Those files, BrowserBench, for example, if you start them, they will start download. What? Okay, never mind. If you start those applications you can find on the internet, they will start downloading a small image, then a larger image, then a really large image, and then they will start uploading stuff to a server and measure how long it takes to download and upload those things. You can do that with JavaScript too. You can create an image in JavaScript and point it to a file where you know the exact size, and you could measure the bits per seconds. I just explicitly didn't say bits per seconds up front because that's too accurate for the approaches I used. The thing with those, you could probably find a polyfill doing that, or you could write your own polyfill doing that. The thing with that is you have to download megabytes and megabytes of data just to figure out what is a good to figure out if you're on 4G or on 3G or stuff like that. And that is not what I want. If I'm on a slow end device using my mobile data, I do not want the user to download 5 megabytes of images that he or she will never see, just to figure out that he is on a low end device, slow connection. So right. That is the reason I didn't look into polyfills for that.
Yeah, I guess I was assuming that, you know, whatever Google or whatever Chrome is doing to like watch its own network traffic, I guess the browser's already going to be loading things, so it's probably checking to see, you know, how long did it take to get this thing of a certain size. So it's not loading anything extra in order to figure out what its overall speed would be. I didn't know if there was something similar that you could do that would essentially be like an HTTP interceptor in Angular, watching how long it takes to load certain things and then gradually updating that information as you went. I'm sketching it out in my head. I could see how something like that might work. I just didn't know if there was anything like that already.
Well, we are all senior developers or kind of senior developers, and what senior developers are doing all the time is they Google. I just Googled while we were talking about it, polyfill navigation connection. And the example just shows me one polyfill. And so there are polyfills out there. I do not know how they work.
You have to be careful, because if you guys nerd out too much over this polyfill, you're not gonna have time to nerd out over the machine learning.
You're right. But I didn't look into it. Just to keep it short, I didn't look into polyfills because I felt like every polyfill would have to use the same technique I used, but with bigger data to be more precise. But I like the idea of using the HTTP interceptors to measure the timing of loading stuff there. So maybe in a future version of this talk, I will add that.
We can let Bill do the follow-up there, put him on the spot.
Sorry, I didn't hear that.
We'll put Bill on the spot to do the follow-up.
Saying that if I volunteered to write that.
Good job, Bill.
Okay.
Can't wait to see that. We'll look forward to that. Bill's going, oops.
No uploading place.
No uploading place. You have to say it in German. We're from Berlin tonight.
What do I have to say in German?
He said he doesn't speak English, but he said it in Spanish, and I told him to say it in German.
I really
okay.
say it in German.
I actually think Martin's doing amazing because he's jet lagged, and it's the middle of the night, and he's speaking a different language and answering all these technical questions, and I think that's amazing.
Thank you, Bonnie.
You're welcome.
You just mentioned, let's geek out a little bit on machine learning. So the third scenario, and that is the scenario why I came up with that talk originally, is user behavior. Your user changes the way they use your application. And if you have a large application, they often just do one thing in the application, and after time, you can see that they using your application always the same way, even if they have multiple ways to use your application. And the question is, how does the user use your application? And then only load those lazy modules the user will need next. So if you, for example, have a form to add a new data set, he or she will probably look at it afterwards, so loading that one would be a good idea. This is really good for large applications that have a lot of lazy modules, so modules that have their own routings. And an easy way to think about that would be a funnel. So if your application is a funnel, I just jumped to the whatchamacallit, to this drawing. If your application is a funnel where you just can go from module A to module B to module C to module D, it would be super easy to create the preloading strategy that says, okay, I'm in module A, I will preload module B. I'm in module B, I will preload module C, and so on and so forth. But to be honest, I asked the question at ng Party in Prague on their meetup if anyone has an application that really works like a funnel. And just one person showed up. So there are applications out there, but that was 1 out of 30 or so. So yeah, that's in reality, that's not really a thing.
I have to tell you, Martin, I was laughing when I was watching your NG Vikings, and you started on this slide, especially. And the next one I was cracking up because you were like, so the easiest way to explain this is if your application is like a funnel, and it's like very soothing and non-threatening, and this is really easy. And then you go, does your application actually really work like this? No. I was laughing. I was like, no, you can't do that. Sorry.
So, yeah, it looks a little. In reality, looks a little bit more like that. So in reality, you can go from module A to module C to module B, but not to module F, except if you change the URL. And if you look at real applications, most of the time they have a navigation bar on top. So in reality, you probably can go from anywhere to everywhere. And for that reason, you have a quite complex graph telling you where to go. And this graph, you see, just triggered in my head, okay, I know that. That looks exactly like Markov chain. So I thought about machine learning, and now just really, I want to make it easy for everyone. So if you never talked about machine learning, do not quit the stream yet, because I won't do math. I will give you a brief introduction and on various things about machine learning. And for me, it's important for you to understand machine learning is not really all about the math, and it's not all about neural networks, and it's not complicated. A lot of it is quite old and quite easy to understand if you give a good drawing and remove all the complicated math symbols that are used. They are just there to mislead you. It's really easy. So for example, machine learning Wikipedia, just look it up. For example, you have classifiers. Classifiers, you know classifiers. Classifiers are, for example, your spam detector in your emails or stuff like that. And you have classifiers like linear regression and naive Bayes and decision trees. And I'm hoping to not misquote someone, but I think it was a dynamic web page is her Twitter handle. And she said, if you can draw a line from the lower left corner to your upper right corner, and you have a two-dimensional coordinate system, every data point above the line is, for example, not spam, and every data point below the line is spam. And voila, you did machine learning. So it's really easy. It's just like drawing a linear regression line. Or decision trees. Decision trees are nothing else like a flow chart where you decide, okay, the weather is sunny outside. It's more than, okay, do not do degrees. It's sunny outside and it's warm, so I can wear trousers. Or if it's sunny outside but it's snow is on the ground, I shouldn't wear a t-shirt but a sweatshirt or something like that. So this is a decision tree that's really easy to draw on just a piece of paper. And the algorithms behind that, you do not have to understand all the algorithms. You just have to understand how they work to use them.
I have a question.
Yeah.
Because I have not done anything with machine learning, and it always seems a little confusing to me. But I know certain people that when they start talking about machine learning, their faces light up and they get all excited, and this is really cool, right? But I'm thinking, so from what you've just explained and from what you were talking about earlier, if we go back just a little bit, that we were talking about the different types of devices that people might use for mobile, right? And then you had the timeout on your strategy where you could have slow loading and lazy loading. So if you set your machine to look at that timeout and look at which flag you got back, and then collect all of the different devices and figure out which ones usually are slower or which ones might be more commonly, and then you could, by that, figure out which ones are maybe older devices or not the latest fancy devices. Is that considered machine learning?
That is exactly what you would do. That's exactly machine learning.
I just ascended to the next level of nerdiness, you guys. You saw it here.
Yeah. You didn't see me nodding all the time, but I was nodding all the time. That's exactly what you can do. You can just collect the data. You can use, for example, when you're on Chrome, the connection API, and mark your timeouts or your timings with 4G, 3G, 2G or stuff like that. And then you can use something like a decision tree to learn from that data if you're on a slow connection or a fast connection. That is exactly it.
So you set that up, and if you were going to do something like the example that I just mentioned, you would set it up, and then you would wait, and because you have to have the data come in, so you need a bunch of different devices to load your algorithm, and then the longer you wait, the more devices use it, the more accurate your data will be.
Correct. Right. That's, yeah. You have to have data. You have to collect those data. If you have already application, maybe I jump a little bit forward into the slides. If you have already data, an application, and you use something like Google Analytics, you already have a lot of information about your user and how they use your application and what they're using. So you could also just start by doing the timeout thing or the new date get time code I showed you, and pass that to your Google Analytics, and you're done. You just have to wait. Your user wouldn't see a change, but you would get the information about, and then you can use that information to train some machine learning classifier algorithm if you have a slow internet connection or not. I'm proud of you, Bonnie. That is the perfect example. I didn't think about it.
Wow, thank you. And actually, I'm proud of you too, because I know I've heard the term machine learning, but I just didn't really dive into it because I've got so much other stuff going on. But that was probably the simplest explanation that I've heard so far. So now I feel like I know all about it. Have you? You know about machine labs, right?
Yeah, sure.
I think everybody who's excited about machine learning should go check out machine labs. If you don't, you probably already know if you're one of those machine learning people that you probably know. But if you don't know about machine labs, you could go check it out because it's Pascal and Dominic and Christoph, and they're awesome.
Yeah, and what you can do there, you can just use machine labs to do all the. They use pre-implemented versions of a lot of algorithms, like everything I showed you here, linear regression, decision trees. Just have to use them and feed those machine labs information, and it will run and it will show you the result, and that's it. So yeah, it's a really easy way to start with machine labs. Next would be, for example, I just said spam detection is a perfect example for classifiers. Also, if you have Google Mail, for example, Gmail, I'm from Germany, you can say, you can tell that because I say Google Mail. If you have Gmail, you have all those tabs in Gmails that tell you that this is an announcement and advertisement or stuff like that. That is also done by classifiers.
And they have images. They used to have CAPTCHAs with letters and numbers that you had to type in to prove you were a human. But now they've been doing a lot of it with image, and I think they're using us all as machine learning for their image recognition software.
That's true. I will come back to that example, what they do, because as Bonnie just said, you need labeled data to train. So you have to have humans to label all the data, or in our case, users to label all the data, so we have information to train our applications. That is a special thing for classifiers, neural networks, and all of that. If you do not have labeled data, you would use clustering algorithms like k-nearest neighbor. I won't go into detail what it does, but you don't have to have labeled data. What it does, it just looks at your data and says, okay, that looks like it belongs on that pile of data and that belongs on another pile of data. And you would see that, for example, in recommendation systems like, all know the famous, you may want to also buy this or that on various big market platforms. Yeah, if you want to say Amazon and Netflix. I think Netflix doesn't use k-nearest neighbor for that, but yeah, recommendation systems. They're just the best thing for clustering. And
yeah, this is why when I buy a vacuum on Amazon, it keeps asking me if I want to buy another one.
Right. And they need data. They need a lot of data. And recommendation systems aren't that easy, to be honest. It feels like that shouldn't be too complicated, but it is quite complicated to build them. So ignore the clustering. Go straight for classifiers. Classifiers are really easy to use, and you can do a lot of stuff. I have another talk where I used one of those classifier algorithms to detect if you're drawing a rectangle or a circle or a triangle, and you could use that on mobile phones to do shortcuts. So you don't have to have complicated algorithms to do that. That's really easy with classifiers. Third big thing are neural networks. I just pointed out 2 versions. There are really a bunch of neural networks. And for example, what we do with the captures, we label the data so the neural network knows about the data. So you also need labeled data, and the problem with neural networks for me personally is they're really hard to visualize. So a decision tree is, you can draw a flowchart on a piece of paper and your product owner understands it. I draw it on a piece of paper, my mom understood it and said, okay, I understood it. Now let's go to neural networks. And I said, no, that's really hard to visualize. You can use that for image recognition. There are a lot of APIs of various big companies like Amazon. No, I'm not sure about Amazon, but Google TensorFlow. You can use Google's TensorFlow, or you can Azure, and you can use image recognition just to tell if on a picture is a chair, a crowd, a laptop, something like that. And you can use it for quite a lot of things. And the thing I will talk about a little bit more are stochastic models, like the Markov chains or hidden Markov models. So especially if you look at Markov chains, they look just like a state machine. For anyone who didn't learn computer science in university or does not know what a state machine is, that is more or less a state machine. You have an initial state. Let's say module A is my initial state, and then it says, okay, I go from this state, module A, to this state, module C. The arrow is called a transition, and the circles are called a state. And this is just a state machine. That's it. And I have to find my slide back. Right. And what it does, it just adds probabilities to each transition. And don't be worried, probabilities may sound like a lot of math, but in the end, they're just a number between 0 and 1. And that is all you have to know about probabilities for those models. If you take into account which module you really looked at, you can get a hidden Markov model. So that is a little bit more complicated. I just want to point that out. I do not want to go into details with hidden Markov models.
I'm just curious where that word Markov comes from. I've never heard that before. Is that the name of the person who figured that out the first time?
Yes, that's a
good guess.
Russian mathematician. Their base, for example, you saw base a little bit earlier. There's also just a mathematician. That's a hard word. A person who did math. And almost all of those algorithms are named by more or less their creator. You know those hidden Markov models. If you have a look at your phone, and I think every phone now can do the word prediction. So if you start typing on your phone and say hello, and you start HEL, it probably will show you hello as an option, and you can click on hello, and it will autocomplete to that word. And if you start by typing HO, it may show you Houston or Honolulu. And what happens behind the scene is you have a Markov model. So every language has a probability that after the word hello follows the word world or something like that. So this is hidden Markov models. This is just the probability that after one word follows another word in a specific language. So if you change your typings at your keyboard to another language, for example, you will get a different prediction for the next word, because different languages have different following of words. And yeah, you use it all the time. I think, at least I do use it all the time with typing word predictions. So what would it look like in our case? I just showed you that, and I just told you this is what a state machine would look like. And if you want to make this a Markov chain, you just have to add probabilities. And as I just told you, probabilities are nothing more than a number between 0. That means there is no possibility to this ever happen. And for example, you can see the transition from module C to module F, because there's only one outgoing link or edge from module C to module F. The probability is 100%. It will definitely go from module C to module F. So you would have one there. And if you have a look at all those edges, we have outgoing edges and incoming edges to every of those circles of those states. And the probabilities of all outgoing edges always has to sum up to 1. That's just a rule. And you can get those informations just by looking, for example, if you set up your Google Analytics correctly, or you use PVIC or stuff like that, you will probably already have this information somewhere hidden there. So this looks really good, but machines do not work well with drawings. So the best next thing machines are good with our arrays. And you can do exactly the same thing like we did in the previous slide with just a two-dimensional array where your rows are the outgoings. So this is all outgoing edges, and the columns are all ingoing edges. So for example, module A just has one edge from module E that is incoming. If we go back, A just has one arrow that points into it, and E has 2 arrows that point out of it, outgoing edges, and that is to A and B with 0.1 and 0.9. And if we have a look at it, 0.1 and 0.9. So this is the outgoing, this is the ingoing, and this is it. You just created a two-dimensional array. In math, you would say you created a matrix, like the movie. And this is it. You just created a model. And the question, I already told that multiple times, you can get this information from various trackings, from Google Analytics, from PVIC, what is renamed to Matomo. If you do want to have it all on your own, use PVIC. You have to host it yourself. If you want to go to easy way, go to Google Analytics. Or if you do not want any tracking, just create a service in your application that collects the data and use some endpoint on your server where you tell the server, okay, a user got from module A to module B. Did you understand me? Did you save it to the database? And the server tells you, yes, I did save it to the database. And as Bonnie just mentioned, with the slow connection and the learning, you have to start by collecting data before you can create those Markov models. The Markov chain needs information. These numbers, I just made up this entire model and all those numbers, but in reality, those numbers come from how your user uses your application over time. So yeah, this is how you get the data and how to use it. I will jump into the code. That is probably just a little bit better. So what I did, I created 2 new services. One is the preloading strategy itself, and one is the Markov model. Here you can see, I was lazy. I just created a 2-dimensional array of numbers. This is my model, and I just push the rows of what you've seen here. So this is the row of A, B, C, D, E, F. In reality, if you use that, if you use Markov models, you would store them on the server, and you would recalculate them, for example, every night or every week. You do not have to recalculate them every request, because they won't change that often once you establish them, and you just would get them and store them in the model. And this is where all the magic happens. We just tell, in the service, we just have two methods. One is to update the current module. You just say, okay, I want you to know that the current module is module A. Give me the next module. And what it does, it goes to get next module. And this is, by the way, this is at least another good thing where functional programming is really helpful, because I don't have to show you the code that is above line 74. I just can tell you, okay, I'm looking for the index of a module name, for example, module A, or I'm going to get the row of the model, and then I just check out which of those columns has the highest value. For example, if we look at line E again, the second index of 0, second index is 1, the second index would be the highest number. So for example, this would be 1, and then I get module B back. That's it. The function itself there, just switch cases I used for this example. And
hey, Martin, Kyle distracted me for a minute because he made me go and look up Andrew Markov, and so it's Kyle's fault. He distracted me. But I just want to make sure that I understand, because I missed 1 second of that. What you're doing when you're the numbers that you have in your Markov model are the probability, because you were looking at that. We were talking about routing earlier and preloading strategies, right? So basically, what you're trying to figure out is what is the probability that I'm going to go from module A or component A to component C or component B, because if it was linear, it's very easy to load the next one. But because it's not linear and you don't know what they're going to click next, that's where you're getting your numbers.
Right. If you look at the example, the example application always has a few go-to links on the bottom. They are exactly match this drawing I have here. And if you go look at module A, you have module B and module C, and you have the link to module B and module C. And everything that I say is 8 out of 10 users tend to click on this link, and only 2 out of 10 users tend to click on that link. That is everything I'm saying. That is all the model says.
That's
and if
so
I'm
cool.
going to module B, if I'm going to module C, or module B, I'm sorry, there are 3 out of 10 users are going to click on the link to module C, and 7 out of 10 users are going to click on module F.
Kyle wanted to know in the chat, is it necessary to do that lookup calculation at runtime? Or can you simply store a map from the current module to the most likely next module?
You just store a map, or in my case, a 2-dimensional array. You can store the 2-dimensional array and load it from a server and just calculate it, I don't know, every week or so. That's totally fine. You don't have to do it on every request for every user. Also, in the simplest way, this model looks exactly the same for every user. So you do not have just a model for Bonnie and one for Bill and one for Rachel. You will have one model for all users. So this is really that's really simple. That's it. And what happens if you look at my module A, they are all the same way. What I do is, in the component that is executed as okay, maybe it's a little bit slower. Module A, ng module A says that component A component is the component that is used when I go to module -A, -A. And what I do in a constructor is I get the activated route. To be honest, this could also be just in the data or somewhere else. And I use my Markov service and say update current module, and I tell a behavior subject here what the next state will be. And what I do is I just give it a string and say, well, okay, I'm module A, and I calculate that the next module will be, and then I just do next on this behavior subject and do it with the string module -b. And the preloading strategy is nothing else than we are using the fact that preloading strategies use observables, and observables do not have to be executed on the time when the method preload is called. Preload will be called just right after the initial application started. But the observable can take its time. So we are listening to this stream of data, and we filter for the one module that is the same name as our current module. So for example, if this is run with route A, module app module A, with this, and we see that module A is picked, it will filter, okay, module A equals what I have, then just do call the load function, and this will return the observable to load that application. And with those two services, and of course gathering the data and calculating this two-dimensional array, you just did preloading strategy with machine learning. That's it. Questions?
That's very cool.
Yeah, this is really intense. I'm going to echo something I did see Kyle say earlier in the chat as well, that this seems like a fantastic solution for a really high-class problem. How often do you really need this? I mean, this is a lot of really cool stuff, but it seems like it would have to be a pretty advanced application with lots and lots of users, or a pretty big application, I guess I would say, with lots and lots of users for this level of complexity to be added to it. So I guess maybe I'm asking, how are you using this in the real world?
Well, in the real world, you would have an application with many modules, with many use cases that does a lot of things. I'm talking about 30, 40, 50 ng modules that are more or less could all be their own small application, if you say so. You could, if you think about those routed modules, about those modules, you could easily just create an own application that only does everything that is in module A. That is how the architecture of Angular works like. And you have to think about application that does a lot of this. Yeah, we are talking about large scale applications. Do not do this if you just build a to-do app or a small app. If you're going to have 20 ng modules or something like that, maybe you start considering it. Yeah. Did that answer the question? Large applications, really large.
Although you've kind of convinced me that, once this is in place, it could be just like PreloadAllModules is a great default loading strategy. If this were generic enough, you could make it kind of your go-to default, and it would collect up those statistics over time, throw them into local storage, and then for the user that was using your application, it seems like this strategy would learn over time pretty quickly how this particular user uses your application and start doing the right thing for them. Is that reasonable?
Yeah, sure. If you could use your local storage and do just the model for one user, and you would have the exact same. Yeah, you could do that. That is definitely doable and quite should be doable quite easy, to be honest.
Yeah,
you know what I like about this? I like this explanation because the way that Martin explains it, I think is really simple. And if you understand machine learning and what machine learning is, then the average developer will, I mean, once you like have that in your brain, you're going to be able to find different ways, because it just seems like this is like, I mean, I've heard of machine learning before, but it just seemed a little bit out of reach, and it seemed like kind of something pretty complicated. But when you explain it in this way that just really makes it simple, you can think of all kinds of ways. I mean, it's basically like A/B testing, kind of.
Yeah, sure. Yeah, it's kind of A/B testing. You just say, okay, the probability that you say A is the same as if you go to B. In the end, A/B testing is a lot of stochastics and math behind it to figure out if test A was better than test B. And it's the same math, the same stochastics that happen to be used in Markov models. So yeah, I feel like I just volunteered to make this make a slick, small library that provides a preloading strategy for Markov models with local storage.
Yes, you did. Good.
Yeah. Thank you, Martin. We're looking forward to that.
Heard that? Yeah. That's a problem when you're live. You cannot. You have to do what you say. Yeah. But yeah, you could do that with local storage. I think it would work if your user uses your application. If your user uses your application often enough. So that is almost always the problem. If you do not have enough data, it's really hard to figure out what to do.
Well, you could start off with reasonable defaults, and it certainly wouldn't be any worse. And then as the user uses the application more often, it simply gets smarter about their particular habits. So yes,
right.
You should totally do this. This sounds great. And then Kyle said you should then get it included in Angular in the box, and then Angular will just be magic by default.
There you go. So that's good, something good for you to work on next week, Martin.
Next week.
How about we let him get some sleep first?
Oh yeah, he probably should get some sleep. I can't believe you're not delirious at this point, Martin, after what you just got back from Japan, and you probably haven't had any sleep, and now we're picking your brain.
Well, he does.
No, I just worked the 2 days. Just not worked 2 normal days. I came back on Tuesday 1 a.m. my time. No, Wednesday 1 a.m. my time, and I started working Wednesday. And today, just my sleeping schedule just is not in sync with Germany right now. So it's kind of fine. Feels like it's 10 or 11 in the morning right now.
Well, you're awesome.
Just at the end of the day, of the German time day, where it gets hard. So tomorrow.
Well, speaking of the end of the day, I hate to break up this party because this is really fun, but we are getting close to a 2-hour broadcast. I really think that you should come back to ngHouston more often. And if you ever want to do a YouTube channel for your Berlin meetup, let me know, because I would be happy to set that up. And then we could send Corey Ryland to do a remote meetup for you. And I also think it would be a lot of fun to get you and Pascal and Dominic Elm all on the same, and probably Kyle would jump in on that one too. I think it would be cool to get you guys all on the same episode and just have an episode just for machine learning, because this machine learning thing was kind of at the end of the lazy loading episode. And I think we might have lost a couple people, but then again, we might have a couple people that are really excited about this and think it's very cool. So I think it would be fun to do an episode just for that, but you definitely should come back on. And I don't want to cut you. Do you have did you finish? Was that your last slide? And do we have any more questions?
You did not cut me. That was more or less my last. I did the conclusion just. I didn't show you the conclusion, but it's what we talk about. Just one more thing. If you have any further questions on this, my DMs on Twitter are open. Just contact me on Twitter, chaos_monster. I'm really happy to help out, and I will tweet to ngHouston the link to the repository if you want to have a look at the example repository. We do, and this was really fun. And I want to say thank you for coming on, and thank you for staying up in the middle of the night
and coming to visit us in Houston. That was awesome. And I think this was a great presentation. Really, there were some things in the beginning that I think were great for everybody, because there were things that, maybe not everybody knew. But I mean, this machine learning thing, to me, I think it's cool. I know it's cool, right? Because I know some very cool people that get excited talking about machine learning. But I think this was the first time really that I felt like I understand it. And now I know what machine learning is and what it's about. And to see the way that you broke down your example and you actually put it into code that we could see it, and it just makes it now not quite so intimidating, because it doesn't seem so confusing. It seems pretty simple as machine learning can be. So that was really cool, and I really appreciate you breaking it down and making it to where everybody can understand it.
Just don't be afraid of machine learning. It's easier than it looks like if you start small. If you don't want to start huge with neural networks and stuff like that.
Yeah, I think that was awesome. That was a really good explanation. Bill, Paul, Rachel, any final thoughts?
No, I really enjoyed this. This was great. I really do look forward, though, Martin, to your new module that you're writing. So let me know when that's ready, because I got some applications to plug it in.
Yeah, hurry up, Martin.
Yeah. Okay.
As soon as you've had some sleep.
Yeah, maybe tomorrow. Or next week.
What do you think, Rachel? I'm picking on you. Are you going to come back and do another episode with us?
Sure.
That's awesome. We would love to have you. We don't get too many girls on ngHouston, so we need more. We try to encourage more girls on ngHouston. Okay, so I think that's it. We're going to wrap it up. And it was great having you on, and we will see you soon. Don't be a stranger, and please come back and visit us often and say hello to all your Berlin friends.
So bye-bye, everyone.
Take it easy.
Good night.
Bye.